Hello, this is Akshay with another video here, and this time around the video is going to focus on the NCERT example as far as the numerical problems are concerned. So this very example is exclusively, you can say that is exclusively focused on Ohm's law there. So, but you have learned in Ohm's law that's gonna be applied over here. And if you are not having a clear-cut understanding of Ohm's law, then I am directing you to visit my previous video, detailed, you can say, explanation on Ohm's law over there. So let us go through the statement of this very numerical problem. The potential difference between two terminals of an electric heater. Here it is the electric heater I have taken over here, and these are the two terminals, and the potential difference is being applied to the two terminals of the electric heater, and this is 60 volt. Here it is, potential difference is 60 volt being applied. So the potential difference between two terminals of an electric heater is 60 volt. Then उस वक्त 60 volt होगा, then it means electric heater, when it draws a current of 4 ampere from the source. This is the source, and heater is drawing 4 ampere current from it. So here current being drawn by the heater is equal to 4 ampere, because as and when the heater is connected to the potential difference or the battery, it begins to draw current from the battery there, and current being drawn over there, it is 4 ampere. That's the first part, and I have put it as case number 1 when potential difference is 60 volt here. So that's one. Next is what current? Here it is. This is gonna for a question here. What current will the heater draw if the potential difference is 120 volt? Yehi same heater, the heater. Here you can say the heater. It means the heater remains the same. Heater does not change anymore. It means whatever the coil being used in that very heater, that coil will remain the same. That's why here the article being used is the heater. It means heater remains the same, but the situations are undergoing a change. And the situations, what situations are changing here? That is the potential difference being employed of 120 volt. And we have learnt, obviously, this numerical is quite a clear-cut, you can say that is the example or clear-cut explanation or clear-cut, you can say, reference to the Ohm's law here. That is, yes, as the potential difference changes, so is the current. And that's why it is being asked, if new voltage is being provided, then what's gonna be the new current? So that's all about the numerical problem, case 1 and case 2 we are gonna discuss here. So let us take whatever it is given there, that is when potential difference is 60 volt. Here it is potential difference it is given 60 volt, and current which is drawn here, that is current I is equal to, that is 4 ampere. So what we are gonna do here, firstly we are going to find out the resistance of that very conductor, that what's gonna be the resistance of this very coil present in the heater. From this very case we will find out the resistance, and then we will visit over here, because we have found the resistance over here, then we are gonna use that very resistance here. So we are knowing the voltage as well as the resistance over here, we can easily find out the electric current flowing through the conductor. So that's what you can say the way out of this very numerical problem. So here the two ways to attack this very numerical problem. Firstly is directly coming from Ohm's law. That is, yes, you know that Ohm's law states that I is directly proportional to potential difference. You know, when the potential difference 60 volt, then the current is 4 ampere. Now what is being asked here, कि बताइए कि वोल्टेज अगर 120 वोल्ट हो जाएगी तो करंट कितना चलेगा. अब आपने देखा ये 60 वोल्ट है, वोल्टेज कितनी हो जा रही है, इट इज डबल ऑफ 60 वोल्ट. अगर वोल्टेज डबल हो जाएगी तो करंट भी डबल हो जाएगा. सिंपल सी बात है, बिकॉज current is directly proportional to the voltage or the potential difference acting across the ends of a conductor. If the voltage is gonna double, so is gonna be the current. So here the 60 volt, at 60 volt potential difference current is 4 ampere, but at 120 volt means voltage या potential difference जो है वो double हो रहा है, तो ये जो current है it's also gonna be double the voltage, double the current. flowing through the conductor, and 4 ampere का अगर आप डबल करोगे, our answer is gonna be 8 ampere. 8 ampere जो वो आंसर आएगा, that's directly coming from Ohm's law there, and which states that current flowing through a conductor is directly proportional to the potential difference, double the potential difference, double the flow of electric current through that very conductor, and hence the current flowing through that very heater is going to be 8 ampere. So that's the first way. That's the first way to attack this very numerical problem, and that way is directly coming from the conceptual clarity about the Ohm's law here. Now mathematically, but we are gonna do in the very first case, both the quantities we are knowing, voltage is there, current is there, we are gonna find out what is the resistance of that very heater. Once we find out the resistance of that very heater, this resistance is gonna be employed over here because heater remains the same, and we will use this very value of resistance over here, and then we will find the current there. So this very, you can say, Ohm's law triangular technique is going to be put into play here. It is voltage, it is I, and it is R. In the first case, see, we bound to find out R here. Here it is R. So R is equal to V upon I. Very simple. So according to Ohm's law, according to Ohm's law, V is equal to IR, or R is equal to V upon I, as I have told you over here. V upon I, or R. Now R is the resistance, V is the voltage, I is the electric current. R find out करनी है. V कितना है हमारे पास? 60 volt, and it is 4 ampere, and this is 15. 4 ones are 4, 4 15. 60, 15, and volt upon ampere. Volt upon ampere is Ohm. Volt upon ampere is Ohm. As we know that resistance is equal to V upon I. The unit of resistance is Ohm, and the unit of volt, potential difference is volt, and the unit of electric current is ampere. So it means volt upon ampere is equal to Ohm. So volt upon ampere is equal to Ohm. So we got here the resistance of a heater, and here it is 15 Ohm. We will say here that the heater remains the same. It means the coil present in that very heater will remain the same. So whatever the coil over here, the same coil is being used over here. So it means the resistance of that very coil is gonna be stable, that's gonna be constant, and it is 15 Ohm over here, same is here, 15 Ohm. So we know now that is the new potential difference is 120 volt. Resistance of the heater is, or coil present in heater is 15 Ohm. Now we can find out what is gonna be the new electric current flowing through that very heater subjected to 120 volt potential difference. So here it is. Now we are in a position to find out I. It directly V upon R. So here, but we are gonna write over here that is since resistance of a heater is 15 Ohm, new potential difference is equal to 120 volt, and it means IN, new current, knew the voltage, knew the current flowing through that very heater. So IN we are gonna in search of, we will find out what is IN, and according to Ohm's law, we know V is equal to IR. Once again I am taking, and I have just referred you to this very triangular technique in order to find out the direct, you can say that is the way out of this very numerical problem. So V is equal to IR. Here we new voltage, new current, but resistance remain the same, or we want to find out IN. IN is equal to VN upon R, as I have told you. This is IB in search of, and it is V upon R. So it is Vn upon R. So we are going to put up the values over here. IN, Vn, how much it is? 120 volt, and R, how much it is? 15 Ohm. And you can solve it. 120 divided by 15, it comes out to be 8. And volt upon Ohm is going to be ampere. And how is it going to be? Let me tell you over here. That is, yes, current I I is equal to V upon R. Unit of current is ampere. Here it is. Voltage unit. Here it is volt. Unit of voltage is volt, and the unit of resistance is ohm. So A is equal to V upon ohm. So here it is V upon ohm is equal to A. So current flowing through that very heater when it is subjected to 120 potential difference is equal to 8 ampere. So same, if you are applying Ohm's law over there, then we have just in the very first position we have calculated that what's gonna be the current flowing through that very heater when it is subjected to the potential difference 120 volt. Double the potential difference, double the current flowing through the conductor. Because 60 volt multiplied by 2 is 120 volt. It means 4 ampere multiplied by 2 is going to be 8 ampere. So that's it here, which is gonna tell you about how to apply Ohm's law over there. So that's it here.